This is Manu from Climatrix Data Labs, and in this video we're going to talk about one of the most used features of Pandas library, which is the read CSV. Now read CSV, as you can see, it means reading a CSV file. So when you want to import data from a CSV file, you use the read CSV. What a CSV file is, we'll just talk about it shortly. So provided that you have imported pandas as described in previous videos, and the alias is pd, so this pd for pandas dot read underscore csv is the command. So it imports a csv file and it converts it into a data frame. So once you import this csv file, it gets converted into a data frame inside the Python instance. So this is the syntax for the read csv command. So you'll say pandas.read csv, and then you will pass all these attributes. Now these are some of the attributes that I've taken from the exhaustive list of the attributes. So for instance, you need to specify the file path along with the file name where the CSV file is hosted. Then you have to specify the separator and all these things, right? Some of them we have, like I said, I've skipped because you might not need them more often. But if you are getting scared up by seeing so many attributes, most of the times you will just need pandas.read csv and file path. So pandas is, you can write pd or whatever you have given the alias, and then just read csv and the file path. File path is again the path along with the file name. So these other attributes are required. So these attributes are required once you need some complex import of CSV or some customized kind of import of a CSV file. So let's go to the Python code and explore this read CSV method from pandas. Into the code, I'll just like to show you the CSV file. So CSV file is, this is a CSV file, right? And if you save an Excel file, let's say over here in this folder, and then there's an option of CSV, which is a comma separated value, also known as the comma delimited, right? A comma delimited file. So CSV stands for comma separated value, and it is not an Excel specific file, which means this data need not be an Excel data, right? So for instance, if I put this data in let's say a notepad, and if I separate each value with a comma here, right? If I just try to do it like this, then what will happen is this also is a CSV file, right? So, and then put a comma here in between all these. So this is how a CSV file is made. Now this does not mean that it only opens in Excel. It can also open in Notepad, right? So CSV file is not an Excel specific file. So that's what I wanted to tell. And also it's one of the most used file format because it can be read and worked upon in multiple platforms and systems. So this has a lot of what to say use across different systems. So that's why it's so popular, right? So this is a quick overview of CSV file. Now if this file that I've shown is in on my system, this file, CSV file, is in this folder of my system. I'll copy this path, and if I copy that path in my Python instance like this, so you'll see this path is shown like this, right? Because it's a Windows thing. Windows shows the file path with a backslash, right? Now in this code, I have used this path. I'll talk about the code later, but let's talk about this file path. This is the file path. Over here, I've used a backslash. Over here, I have used a forward slash. So just to keep things really simple and not to kind of make it complicated for the people who are watching this video, try to first see if whatever path your Windows is throwing, if it's working. If it is not, change the slash from backslash to forward slash or vice versa. If it still does not work, right? So what you do is you copy the path from Windows and add another slash. So basically make a double slash, right? Why we do this it would be covered under escape character in strings. But for the time being, just understand if you do it like this will also work if rest of things are not working. And finally, if this also does not work, then put a R like this before the what do you say the path, and this also should work. This is known as a raw string character, this R. So these are some of the ways in which the file path can be denoted. Now assuming that whatever path we use from Excel is working for us, so I'm getting rid of this path by commenting it out, right? And now if we look at the code, we first imported pandas here because we have to use the read CSV. So if we don't import this, let's say if I don't import, if I comment it out, so you see this throws an error because now it does not know what this PD is, and even if I remove PD from here, it will not understand what this read CSV is, right? So read CSV is understood only by pandas, right? So it has to import panda. We have to import pandas before we use a read CSV. Now you see this over here, we have given the entire path, and at the end we have given the file name with the CSV file extension. Very important, you have to give the file extension also. So now if I have this file path along with the file extension, then if I run this code, so you will see our data frame df, because we have named it as df, uh, gets created. It says the size is 640 by 5, which means it has these many rows and columns, and there's some other details over here. If I click here, I'm using spider, so I can have a look of the data frame here. Different IDs show the data frame in different way, and I have the headers of my CSV file and the rows, and it has automatically added this index number. Mind you, this serial number was a column in the file. If you see the file over here, it has a serial number column already. So we could have also said that please take this column as the index column. In that case, Python would not have created this index column, right? So because we have not specified, it has created this index column. And now this data frame is imported inside the Python instance. Now file path, this is one of the parameters we discussed here. Separator, by default it's a comma separated value, but you can change this. So if you want a separator to be, let's say, space, or maybe something like this, right? Or I mean, this is maybe a semicolon, right? A semicolon like this. So you can specify a different kind of separator. Separator, like I said, it means what is separating different values in your CSV file, right? So I mean, the separator would be like if the data is state and then district, so you're putting a comma in between, right? This is how you're separating the columns and all the data points. Okay, header, you can specify the header, or you can just make Python do the work, right? Index column, so on and so forth. So names is like a list of column names, index column. So just to give you an idea, I'm saying serial number is the index column. So in this case, if I run the code now, you'll see the data frame now does not have the index column that was automatically created, but the serial number now serves as the index column. Let's also talk about few other attributes over here. Let's also talk about use calls or with use columns. So if we use calls, this one, right, and let's do it in in another fresh data frame. So let me create another data frame df2, and then if I say use calls, and then I specify these columns by putting them inside the square bracket, and let's say these columns are let's say I just want to use district and state just for demo purpose. So if I say use column district, and then in quotes comma, and then again state, right? So if I use it something like this, right, and then I close the square bracket, and then I have to close the parenthesis also. Sorry, the square bracket like this. So if I run this, and then I've just made some adjustments. So if I now run this, so you'll see a div2 is created, and this time I'm just having only these two columns because index I've removed already. So if you compare it with the other data frame, which was the original data frame, you will see that in the original data frame we had so many columns, but in the new one, df2, this one we have only two columns because you have said use call. So which means if we have a bigger data, let's say maybe 20-30 columns, and we just need 3-4 columns or maybe 5-10 columns, then we can use only the one that we need. This will make our data frame ready. This will make our data frame light, and which will make our calculations very fast because Python will not have to carry a huge chunk of file here and there. Okay. Skip rows is the case when, like for instance, if you have this data and over here you have some blank rows in the beginning, generally you will see that this kind of things happens in raw data. Maybe some data files have some brand name here, company name, something like this. So if you want to skip some rows in the beginning and header is here, so you can specify skip these 4 rows. So that's what skip rows does. And then n underscore values is how you're going to treat the blank. Like for example, if this is blank, let me just give you this another example. So if I just manually do some change my data here, right, like this, and if I sorry, and then if I save this file, right, so now I have deleted one of the data points, and if I run this file, my data frame will have this nan, not a number, right? So how are we going to treat the blank values? This is what n underscore values does. We will cover this in the data cleaning. And then parse dates is if some of the column is a date, then how do you make Python understand that that column is to be treated as dates, right? Very handy feature in time series data, like if you have stock data, time series data and stuff like that, right? So this is a very quick overview of Python's read CSV under the Pandas library, and this definitely needs a lot of lots more understanding, and there are lot many things. But I think once you get going with this command, then these other hidden commands would be or attributes would be explored. One last quick tip. So whenever we're using these commands, right? If we are using these kind of commands where we use the file path, so my personal opinion is if you can keep the file paths and separate, like take any variable, f path, whatever, and keep the file path here, right? And then we know that in strings we can tell the complete path by concatenating, right? So I'm using file path plus India pop underscore CSV. So I'm clubbing the file path with the CSV file, and note the backslash here because that would essentially mean that once this is concatenated, this one is concatenated. So this file name, this one would come after this, right? So, and had I not given this, then it would become something like that, and Python would not understand file path. So if you write your file paths like this, okay, and let's just, yeah, so this way, one second. So if you write the file path like this, I've removed some other unnecessary things. So this way, how it helps is every time once you need to change the file path, maybe you move the location of the file, or maybe you're writing a code for someone, right? And you're testing on your system, and then you're giving this code to somebody else. Generally happens in the teams. Then in that case, if you specify the file path separately, then the guy who's using this code on his or her system can just change this path and the code will still work, right? So he or she has to just change this file path. There are other ways to control the directory or the file path, but for beginners and for people who just trying to explore this concept, and this is a very handy stuff. So I thought I'd give it a go to explain it to you, right? And again, this one is showing an error because it's not reading this backslash. So just change this backslash to double slash and it will work well, right? So this is how your read CSV and specifically this fpath thing works. Very handy feature. So with this, we come to an end of the read CSV function of the Pandas library. If you like our video, then do comment, share, and subscribe to our channel. And we'll be back with more such videos in due course of time. Thank you so much.